Hi everyone, welcome back. Today we will study the thermonic emission which starts and ends with atoms. In this video we will focus on bound and conduction electrons, then how electrons are emitted from metals, then what is work function and thermonic emission. This is a chapter from which you can expect a lot of short questions. So we will go through it point wise. We all know matter consists of atoms, or atoms are the smallest unit of matter. Atom consists of a positively charged nucleus, as you can see in this figure. The nucleus contains neutrons which do not have any charge and protons which are positively charged and surrounded by electrons which are marked by yellow color and which revolves around the nucleus in different orbits. Then the charge of an electron is minus 1.6 into 10 to the power minus 19 coulomb. And so the charge on the proton is 1.6 into 10 to the power minus 19 coulomb, which is equal to the charge of electron. But there is a negative charge on the electron while the charge on the proton is positive. And the charge on the neutron is 0. So suppose if you have 3 negative charge or minus 3 and you have 3 positive charge plus 3. If we combine both minus 3 plus 3, it comes to 0. So the atom becomes electrically neutral. Why? Because the number of protons is equal to the number of electrons. One thing from here, what we knew is that proton charge is same as the charge of an electron, but proton is positive and the charge of an electron is negative. What about the size, you may ask? It's like this. The size of an electron is very small in comparison to the size of an proton. So size wise, electron is much smaller than proton and neutron. But the amount of charge is exactly same, but electron is negatively charged and proton is positively charged. So this is how an atom is arranged. And we can also see from this figures that there are many electrons which are revolving around the nucleus in a definite orbits. Now, what is bound and conduction electrons? Now, as you can see from this figure, this plus charge shows the nucleus part, and all these electrons which revolve around the nucleus in definite orbits, right? Now, the bound electrons are the ones which are close to the nucleus because they are tightly bound to the nucleus by the strong attractive force. Whereas the electrons in the outermost orbit, which are the outermost orbit? This orbit. So the electrons in the outermost orbit are very weakly attracted to the nucleus, and so these are loosely bound. These loosely bound electrons are called as free electrons or conduction electrons. These conduction electrons or free electrons remain inside the solid. As you can see in this figure, this is the particle arrangement in a metal. Metal is a solid. So there are different atoms arranged. And what happens? And as we know, free electrons are the electrons present in the outermost orbit. So these electrons which are loosely attached and they are free electrons. So these electrons remain inside the solid or inside the particle. Now what's the difference between atoms of solid, liquid and gas? The following diagram shows the molecules of solid, liquid and gases. As we can see from this figure, the atoms in a solid are very closely attached to each other. The force of attraction between the atoms of a solid are very strong. Whereas in a liquid, we can find the force of attraction is weak, and in gas, it is the weakest. So this is the difference between atoms of solid, liquid and gas. Now process leading to emission of electrons from metal. As we have already studied that there are free electrons or conduction electrons which are loosely attached to the nucleus but are present inside the solid or are present inside the particle. Now suppose, let's see this first step. If I supply an energy in the form of heat or thermal energy is supplied to the metal rod, what happens when the energy reaches the atoms? The atoms are energized and vibration increases. So this much part is now covered, as you can see here. First, this much part is covered. Then what happens? Again, the vibration is spread through the material and it reaches till the end. So here, first it was till here and then it is reaching here. Then it is spreading towards the end. The atoms are energized and vibration increases when we supply heat energy. Now, what is thermionic emission? The emission of electrons from the surface of metals when heat or thermal energy is impacted to it is called thermionic emission. Here what happened? We saw that when we supplied heat energy, first the vibration was up to here. Then it spreads towards all the ends of the metal. But the free electrons are still inside the metal. But if we supply energy more than the threshold energy or more than a limited amount of energy, then what happens? These free electrons, as you can see here, what happened? Heat supplied, the electrons become free. Electrons in the outermost orbit of an atom becomes free and then they collide with themselves. And when we keep on supplying the heat energy, what happens? These free electrons escape out of the surface of metal. And this escape in out of the surface of metal is known as thermionic emission by supplying thermal energy or heat energy. So let's see this example also. First, we had free electrons which was inside the material or the metal. When the supplied heat energy becomes more or thermal energy supplied is more, then what happens? The free electrons travels out of the metal surface. Electrons are liberated out of the metal and that process is known as thermionic emission or electronic emission by supplying thermal energy. Same thing here, metal piece, and then when heat is supplied, continuous heat is supplied, then electron is emitted. Now what is work function? Work function is the minimum amount of energy required for an electron to escape from a metal. Sodium is a metal, right? If I supply 1 electron volt, then no electron will be emitted from sodium. I have to supply minimum of 2.3 electron volt or more than that so that electron from sodium can escape out of the sodium metal. So work function is also known as threshold energy. The value of the work function depends only on the metal. As you can see here, this chart shows that different metal have different amount of work function. So work function is indicated by the symbol W and its unit is measured in electron volt. Now, thermionic emission is emission of electrons by supplying thermal energy. So, when current flows, as you can see here, this wire is heated. Then it absorbs the thermal energy. Then electrons move a small distance from electrons are emitted from this metal wire, and you can find the electrons here, right? This escape is referred to as thermionic emission. This is a bulb, electric bulb, and when we supply heat energy by providing current, then there is an emission of electrons. Now, what are the factors which affect the rate of thermionic emission? First, the temperature of the surface. If we increase the temperature of the surface, means the rate of emission will be more. Then, nature of the metal surface. If the work function is less, then obviously the rate of emission will be high, as shown here. If I supply 4 electron volt, then I can emit electrons from sodium, lithium, zinc, calcium, cadmium. But I cannot emit electrons from aluminium because the threshold energy for emitting an aluminium electron is 4.1 electron volt. So it depends upon the nature of metal surface. The third one is surface area of the metal. More the surface area, more is the rate of emission. Now, what are the requirements for a good electron emitter? So, first thing is that the energy or the threshold energy should be low, or the work function should be low. Then second one is the melting point of the metal should be high. Considering these two factors, tungsten is a good electron emitter. Why? Because it has melting point very high, that is 3655 Kelvin, and the work function is also low, 4.52 electron volt. But work function seems high here. So to reduce this work function, we use thoriated tungsten, whose work function is 2.6 electron volt. And if we coat the tungsten with barium or cesium or strontium, again the work function becomes 1 electron volt. So the best electron emitter will be tungsten coated with barium, cesium and strontium, but the work function is 1 electron volt. So these are the requirements for a good electron emitter. So thank you for watching this video, and please keep watching my channel for more updates. I will be soon posting a video on cathode ray tube. Thank you.